So we start this next exam with a series of predict the product questions, and these are going to focus almost completely or maybe completely on carbonyl chemistry. So in our first part, we have a carboxylic acid reacting with an alcohol with an acid present, and so that we should recognize as our Fischer esterification reaction. Part B, we have this diester, specifically malonic ester, reacting with LDA and benzyl iodide, and finally with heat. So we know with LDA that we're going to form this anion of the dicarbonyl. Very, very acidic proton, very easy to deprotonate. And then in the second step, we can alkylate. But what does the acid do here? Well, recall that the acid triggers a rearrangement reaction. This, you may recall, is known as the malonic ester synthesis. And essentially, we're able to make about half of this molecule go away. And what we end up with is the product that we would get had we started this reaction with acetic acid. So that last step, the addition of the acid, triggers the rearrangement, which eliminates out one of the carbonyl groups. Part C, the addition of sodium hydroxide when there are esters present is a hydrolysis reaction. And that's going to allow us to cleave both ester groups. Part D, we have the addition of dibol. Dibol is a reducing agent. And can reduce esters to aldehydes or all the way to alcohols. And it all depends on the temperature. So if you recall, when this reaction is run at low temperature, it forms an intermediate that is stable until we quench it at low temperature, and so we are able to recover the aldehyde. If this reaction was run at warmer temperature, say room temperature, then we would end up with the alcohol as our product. Part E is just an alkylation reaction. It's happening at room temperature, so it's most likely to happen at the more substituted carbonyl. And so we add the more substituted alpha carbon, which is the one on the left, and so our electrophile, the methyl group, gets added there. Part F is a Michael addition because of the conjugated carbonyl. So the compound on the left forms our enol, which then does a 1,4 addition into the carbonyl. Part G, thionyl chloride, allows us to form acid chlorides from carboxylic acids. And then in part H, we have the reaction of a carboxylic acid and an amine with DCC will form an amide.